Hello, everyone. It's nice to be here once again for the continuation of our CSWA exam preparation and tips and tricks. Nice to see most of you here. I'm really happy to see Mr. Edwin, a very big presence here, saying hi. So, congratulations on all the work you do for your SWUG. My name is Waju Sulaimon, the Coolwood of Lagos SWUG. I hope everybody can hear me clearly. Please signify in the chat room, in the chat box so that I will know. We'll be
Yes,
starting.
we can.
Okay. We'll be starting in 2 minutes. Okay, I can see Olatunde Muiz. You're welcome. Dr. Adebayo, Kayode, Raimat. You are all welcome. Hope you are all welcome to the session. I hope you enjoyed today's session. So, as Alao Bilal said earlier, it's a continuation because our CSWA is divided into three major parts. That's your parts creation, your parts modification, and the assembly session. So we've treated the first two on Saturday, and we're going to continue with the assemblies today. So brace up. We're starting 11:10 a.m. Okay, let's me begin by sharing my screen. Can you all see my slides?
Yeah, I can see your slide now.
Okay. So, as I said earlier, the title of our session is to Kickstart Your SolidWorks Journey in CSWA Bootcamp. So, we are going to be dealing with the assemblies today, but allow me to just give you a little recap of what we treated the last session. So, who am I? My name is Waju, the CSWE. Uh, Nothing much to say about that. I'm sure most people know about this already. We are going to be dealing with the part 5 today. That is on our page 17. That is assemblies. I don't think I changed the page number. So we've dealt with part 1, part creation, part 2, part modification, and part 3. Sorry, we are dealing with part 3 now. So let me just do a brief summary. CSWA, we all know, is an entry level certification that uh, validates your fundamental skills of SolidWorks software. It is designed for student hobbies and everybody. that wants to begin their journey, that wants to be certified, that want to be recognized in the SolidWorks community. The exam usually takes 3 hours, but most people finish it under 2 hours, or 2 hours 30 minutes at most. So usually also 14 to 18 questions. So there'll be options in the first type of a question, like maybe for a past creation part, there'll be like options for you to select the right answer. Then there will not be what update on that question. There will be build up on that question that will require you to change certain global variables and get the mass required. So, as I said earlier, you need to really pass the exam well. You need to really read the question and digest the question. Your units are very very essential. So SolidWorks exams makes use of MKS, sorry, IPS and MMGS most of the time. MMGS mostly. So always take notes units. Please always take note of your units. The materials, yes. I know some people might be in a hurry to start immediately, but your material is very essential. So make sure you apply the material even before you even start sketching. It's better to always put your material there, like put the right material. One of the things I didn't put here is the global variable. Always add your global variable to first. The global variable, unit, and material is what you should input first before you start sketching. Please take notes. Then the hardware I said is very very easy to use two screens because one laptop can be used for just reading the question while the other will be used for doing the work. Then save copy as and open is very important for each question you answer to save time. After you've answered the particular question, you just click on your save as button and save copy as and open. Then you rename it with another name and continue. Then it's always good to use shortcuts because instead of hovering the cursor over your screen every time, you can just use shortcuts that will just help you get results. Like what you need mostly for CSWA is to know your mass properties, right? So once your mass properties is in the shortcuts menu, you just need to be typing the S key and to show you the command button and you click on it immediately. Then skipping questions, the ones you are not sure that the one that you feel you have issue with, you have a little difficulty in answering. So always shift the next one. So part one, part creation, change your unit, save your work, type in the equation, that is your global variable, apply materials, and we dealt with this question the other day. Please always read the question very well. Take note of the decimal places required to be entered, please. And if you are applying material, always density of the material conforms with the one in the question. Because there are some material plastics, those the same. The density is what actually differentiates the two materials. So we answered an bit of like three questions based on this question one, and we got our result for the Q1 Q3. Forgive me, this is supposed to be Q2, the maths of the result that we got of the model we did. Now, in the part two, the part modification, we did. I hope everybody is following me. So we did at the steps you need to observe the differences between the former model and the result they want you to get the new modification they want you to edit. So observe it very well. Then change your units, modify the global variables. Remember global variables equations, they are like in the same command window, so know that. Then apply the material needed to your map. And always make sure you take a look at all views required of the model. Like this now, these two diagrams, you see there's a difference. there's a cut extrude feature used on the face of the wrench here. You can look at the before and after. Look at here, there's no impression here, but there's an impression here. But if you just use just this isometric to determine that, okay, that is all the changes required, you are going to fail this question. Why? Because if you look at the side section view, especially the G detail, you'll notice that the, the impression is applied both at the top and at the bottom. That's why these two parts are labeled. Do you get? Please always take notes. Look at all your views very well. All the views, all the images provided, make sure you open them one after the other and observe. It is very important, ladies and gentlemen. Then we did what is what required and got our mask. So now, before I go into today's topic, is there any question that is required? Let me check group chat if there's any question. I don't think there's any question yet. Or do you guys have any question before I start today's topic? So can I continue?
Yes.
Oh, okay then. All right. So for today we'll be dealing with assemblies. So assemblies is very easy. It's just how will I put it? Assembly just deals with what? From the name, just adding all the components together and adding mates to them to make sure they are, how will I put it? To make sure they are related with each other with the required steps provided. Looking at the excluded view in the question will also help, and looking at the previous, like the full assembly. Because, and again, okay, let's get started. What do you need? You need to read the question well. The questions related to the assembly are usually longer, so take your time to read it, go through it. Even if it's 3 times, you have to read it so that you can get familiar with all the components given. So go through them, read them one after the other, and understand which part fits into the other. What mate is required to be, what mate is required to join component A and component B together. Sometimes, most of the time, to join two components, you only need one mate. But to join them and so that they fit perfectly, you need two mates. Most of the time, let's just say, for example, coincident and concentric mates, they work hand in hand. So please always read the questions very well. Then change units, as I've always said. Always observe the units. And materials, they are not really, how will I put it? Except you are asked to get the marks, which I doubt you normally ask in this section of the exam. But please always take notes. Some questions they ask you for for like to they put it in the question, they give the mass, yeah, sorry, the material needed. So always take note of each materials, please, and the configuration given. I mentioned something about configuration the last time. I don't know if you guys understood. I said for answering a question now, the question, a relating question that involves you changing global variables or modifying a particular part, you can just easily create another configuration for it. Like a configuration is like another variation of the model you are working on, of the first model, but a different dimension or a different change to a particular feature. Do you understand? So you could do that too on your exam, but it takes time. And because you are working with time, so it's better you just rename, start saving as and renaming each question so that you can progress quickly. Now, make sure your unit aligns with the question because it's important too. In an IPS system that you are dealing with inches and you are asked to get a particular length or you are asked to get a what is usually required in assemblies most of the time is what? Your center of mass. That is your X, Y, Z. We all know what center of mass means, right? So it's what is required. So any slight change, any slight component in the wrong placement can give you a very wrong center of mass. Do you understand? So the weight totally, because I felt the reason why they don't really ask much about the mass of the whole assembly, because they know that no matter what, if you just add everything together, even if you don't follow anything and just check mass of all components, even without assembling all of it, you just add the weight of each component and give the answer. And so that is not much of a challenge. So this uh, center of mass aspect is very easy to miss. Though if you get your if you follow your assembly properly, you won't make any mistakes doing that. So please take note. Now, entering global variables too are needed in this section. Most of the time, it's only just one global variable that is given, but sometimes they give you two. So please always take notes. Always enter your global variable before you even start anything. In your assembly environment, in your parts environment, please. They are very important. Then import parts one after the other and use the required means given in the question. Sometimes you may look at a particular isometric drawing of an assembly now and you be like, wow, this looks easy from the way you are looking at it. Let me just quickly do this without checking. There might be an important detail you missed. Do you get? Please always just do them one after the other. The names of those components, take note of all of them. And it's always very important to download all the parts first before you even start. Make sure it's ready. Make sure it's already downloaded in the zip format. Then it's already extracted before you now start using them. Please always take note. So the base part is the first part that is usually requested by SolidWorks, like the exam. You have to import the base part first. Most of the time, the base part is grounded because that is the part that should be unmovable, so that as other parts is coming in and you're trying to like move them, move a particular joint or and everything, it doesn't make your work look clumsy. Do you get? And always take note. Once you import your base part, it's not every time it's aligned to the origin. Sometimes, most of the time, they will ask you to align it to the origin of your what, of your assembly environment. That's your 0, 0, 0. That is your where your front plane, your right plane, and your top plane meets. That vertex they meet is your origin. So always take note. When they ask you to what, align, bring important base part, make sure you use, as you import it, on ground. Sorry, I've been using the how will I put it, the general word ground. Actually, usually in the fix for SolidWorks is fixed. It's usually fixed, so you have to float it first. You make the part floated, then you do the necessary mix, then you can now what, fix it back. You get, very important. And each relations and each mate should be implemented accordingly. I hope you guys understand this section very well. So let's just uh, with the question. Any question before I proceed with getting started? Hello, any question? Why? Before we
No,
start.
sir. No, sir.
Okay. So now look at this assembly now. Look at this is the assembly of a screw jack, a scissors jack. So it looks easy from the eyes, like, oh, this is something that won't take most of our time and everything. So observe the number of parts there. Observe the number of parts, single parts. Observe the number of parts that are repeated there. It's important too, because you don't want to waste time when you are doing exam. Like, look at this now. Now I've always said you should be conscious of symmetry. Anything that you know that is symmetrical, that you don't you You don't need to be modeling the other side the same way you model the first side. You just need one part and you just mirror. Do you understand? We are not going to use mirror in this case. We are just going to use another feature that I'm going to explain as time goes on. So let's read the question very well. First, you have to download your zip file, extract it as I said earlier. Most of the parts you are going to open during any CSW exam, any SolidWorks exam is if you open the part provided, it will ask you this question. Do you want to proceed with a feature recognition? Please always select no. It's very important so that it doesn't interrupt with any geometry of what you are working on. So always select no when it gives you that you want to proceed with feature recognition. Always select no. So as from this question, you see a global variable of 297 millimeters is given. So you know what to do. Go to your tools, then your equations, then you add the global variable. Then our unit system is MMG. So you should have done our unit system first. Check your unit system, make sure it's aligned, decimal places, part origin, arbitrary. That is for the parts. But for assembly, you don't have an arbitrary origin. You have to make sure it aligns to the assembly origin. Then the material type is this. I think all the parts is this. As I said earlier, they usually give you material. So always take note. It's important. So thank you. Let's proceed. So this is the front and side view of the components. This shows the distance from the top flat part of the screw jack and the bottom part. So always take note of this. So this is just the full assembly. This is the side view. And next question. So it's important, that's why it's in red. Create the assembly with respect to the origin of the base part. What is the base part? The base part is what? The first part you import into the assembly environment. See? As I said here, this is important for calculating proper center of mass. So you create the question now goes thus. Create the assembly using the following conditions. Insert the base as the base part. Now, this may look confusing. All the parts are going to be typed in, like the first letter is going to be in the first letter is going to be in capitals to show that it's very important. The component is important. Look at the difference between this base and base here. So the base is the name of the parts that you are going to insert first into the assembly environment. Then use its origin as the assembly origin. So that means you have to introduce a relation between the origin of the base part and the origin of the assembly environment. As I said earlier, what is the origin of the assembly? Is your 0, 0, 0. Then for the base part too is that value. But for a part environment and an assembly environment, there are two different sessions. So since they said you should insert it first and use its original, that means you have to create a relationship between the origin of the base part and the origin of the assembly. That can be easily done using the coincident mate. And after you've done that, and you make sure that each of the coordinates are pointed in the right direction. The z is facing the z, the x is facing the x, the y is facing the y. Make sure everything is aligned very well before you now fix it back. So if you fix it, that means the part is already unmovable again. So you've done the first one. Then bottom holes of the bottom linkage parts are concentric to the holes of the base as well as pins. So what are pins? These are the pins here. What are bottom linkage? This is the bottom linkage, these two here. So how many pins do we have? We have 4 pins. We have what? 2 bottom linkages. So they now said the bottom holes, that is this part. I don't know if you can see my cursor very well. Is what? Concentric to the what? to the holes of the base. These are the holes of the base, as well as what the pins. The pins too are concentric to this. So are you noticing those things? That means it's telling you that after the base, after inserting the base first, then the next thing you insert is what? Your bottom linkage. Then after you insert your bottom linkage, make sure it's uh, positioned well. Then you what? Add the mate, the concentric mate. Then you insert your pins next, and you what? Make three of them concentric to each other. Now, number three, outer faces of the bottom linkages. This is the outer faces of the bottom linkages are coincident to the inner faces of the base. So this is the inner face of the base. My cursor is. Now, one thing about SolidWorks I like is that if you notice their assembly terms, their assembly mates, the names are also kind of the same with your sketch environment. In your sketch environment, you have coincident. In your sketch environment, you have parallel. In your sketch environment, you have concentric. In your sketch environment, you have tangential, and so on and so forth. So these names, you meet them also in your assembly environment. But in this case, you are what? Trying to link parts together in the assembly environment. While in the part environment, in your sketch environment, you are trying to what? Link objects, shapes together. So that is the two difference. So that is what makes SolidWorks assembly very interesting. So you don't have to be cramming any what is mate needed for this software. No, coincident is coincident, parallel is parallel, angle is angle. Do you get? Linear is linear. So now you click on the face, the outer face of this and the inner face of this is what? Coincident. Now number four, through pins. What are through pins? These are through pins. Are concentric to the top holes of bottom linkages as well as bottom holes of top linkages. So it's telling you what next to insert into your assembly environment. So that means you are inserting your what? Top linkage next, then your what? Through pins next. So this is the top linkage, this is your through pin. So once you insert these two, then you make them what? Concentric as the instruction given here. Always read instructions very well. It applies to every area of your life, especially as an engineer. Even as a person, instructions are very key. So once you've already inserted these two, then you what? Make them concentric to each other as it is done here. So the next thing is to what? Outer faces of the true pins. This is the outer face of the true pin. This side and the other flat side of the true pin are coincident to the inner faces of the bottom linkages. Inner faces of the bottom linkages here. Oh, sorry. I think the outer face of the true pins are this. It's not this smaller uh, cylinder. It's this bigger one. So you are going to mate it with the inner face of the bottom linkage so that it fits perfectly. So I hope you understand that. So the next number six, top holes of the top linkages are concentric to the holes of the top part as well as pins. So the same thing, the same way you apply pins for the bottom part, that is the base part, you apply it for this. That means you are going to import your top part first. This part is called the top part. The name of the part is top part. So you bring it in and you what? Import another pin, then you put it there. Hello, does anybody have want to ask a question? I hope you guys understand as I'm doing it. I want us to give understand. Someone is muted. Who is that? Does the person want to? Oh, sorry, there are some questions here. Oh, sorry. Yeah, you'll be able to. Yeah, let me go through the points here. Sorry. Uh, Hope. I don't know how to pronounce your surname. Is it Cheche or Chechet? You said your device is about to shut down. Will there be? Yes, it will be provided at Berkeley. The study will be provided later. Someone is debating. Uh, someone is. So please mute your mute the call end, Mr. Kyle. Or do you have a question? Mr. Kyle, did you have a question? Okay, then no question. Temitope, can we get the files for assembly in order to practice? Okay, yes, I'll release that. Sorry, I should have released the one for previous class, but due to very certain engagement, I'm going to release all the files I used later. Where will we be getting the recording from? I think it's going to be on YouTube. It's going to be uploaded on YouTube. The files of these sections are usually very large. That's why we normally try to limit them as much as possible. Do you understand? So just bear with us. It might take 1 or 2 days before we'll be able to upload that. But we will upload it on YouTube for you guys to get. Please, Mr. Coyote, do you have a question? Because you keep on muting before I continue. Okay, let me just continue because of time. So top holes of the top linkages are considered to be the top holes of the as well as things here. We've already said that. That's for this part. So the next slide, the inner faces. So as I said earlier, the instructions are usually very long. 10, 12, sometimes 9, sometimes 8. So take your time to follow them one after the other. It's very important. Inner faces of the top linkages are coincident to the outer faces of the top. So these are the inner faces of the top linkages. Are coincident towards to the outer faces of the top. That is the outer faces here. So do you get? While you're ready, the same goes for the pins too. Inner faces of the top linkage. Okay, I've said that. Wait, inner faces of the acquainted outer faces of the bottom linkages. So as you did the same thing for you are going to do it for the bottom linkages because the only relationship between them is still concentric so far. Do you get? So now you have to make them flush. The word is usually flush, like with the faces, the inner faces of the top linkage, the outer face of the bottom linkage. The inner rim of the through rod is tangential to the outer face of the left through pin. So this is the left through pin. Now through rod, you are going to import that. So you are going to insert that, and you are going to make it what concentric to the. Oh, I didn't. I should have read 9 first. Through rod is concentric to the holes on both through pins. These are the two through pins. So this through rod is concentric to the holes in the through pins first. After you've done that, then you now what make the inner ring tangential to the outer face of the left through pin. Now, as I said earlier, each of the images you have to open them very well and look at this detailed view here of this B, detail B. So this is the enlarged view here. You see that the flat of the through rod is what tangential to the what the cylindrical or the curved face of the through pin. So always please always take note of this kind of level of detail. It's very important when you are doing assembly. And the through rod is horizontal relative to the base. That is this is the through rod. If it's horizontal to the top plane, that means it's parallel. That means the plane, its plane is what's parallel to that of the base. Then the top face of the top, this is the top part, and the bottom face of the base are parallel. Okay, that's another that's another image you need to add. Then what? And are separated by distance A. So that's all the instructions. So the question itself is what? Find the center of mass of the assembly in X, Y, and Z. So let's get started. Ah, sorry, I was not supposed to show that yet. Let's do what is needed first. First, we will create our move to our assembly environment. Start assembly. Okay. It will ask you to import first, but don't. You can just cancel this one first, or you just insert your base first. But before we do that, let's cancel it. Cancel first. Change your yes, yes. So change your units to mmgs as question in question. Then come to your tools, your equation, enter the value of our E. 297, right? And so once we've done this, we click OK. Then what is the next thing? Materials, right? But in this case, we are not since we are in the environment, assembly environment. Material is dealing with parcel, so we don't really need that yet. So it's better to know your front, your top, and right lines. So this is the origin of your assembly, as I said. This is your ground zero. This is your 0.0, 0.0. So this part should be regarded to your assembly so far. So you've not imported anything. So now save your work. To, so the assembly section is usually maybe question Q15 G. No, I need to plug it from the Q, let's just say Q20 question. Save as first before we now start using save as copy and open. And what save. So once you've done that, then you can now start inserting components. I hope you guys are following. Please take notes. Insert components. So it will open this window for you where your parts are. So the first one is that what you have to import the base. So select it and you click open. So you can move it to anywhere you want to move. So notice this floating bar here showing your XYZ. So it's always good to know where your XYZ navigation, what do you call it? The coordinate system, how will I put symbol is where your X, Y, and Z are facing. So if you click on this X, now it's to tell you that you want it to rotate the component about X axis. You don't need it like this because sometimes if you import some parts, it will be in a wrong orientation. So you have to reorient it. Same goes for Y. It shows that our Y is what? That direction. And our Z is this direction. So do it to any part you like. Then you just click. Once you've clicked, the first part, as you can see, you see this F letter that is written before the base here. Is to show that what this part is fixed. What I told you earlier, look at our origin now. If you open this down arrow beside your base now and you click on its own component, like its own part, you see that they are different. The origin of the this is the origin of the base, this is the origin of your environment. They are not what aligned. So what will you do first? You right click first. First, you right click on your parts. You click on float. Float means it's already what movable now. So you do what? You click on the origin and this origin too. You know floating bar that comes after you do that. As they appear, you have to be very quick in hovering over them to know which one is you want to select. So we want to use the coincident constraints now. Two of them now share the same origin. So another way to do this might sound a little bit weird. So let me just oppress it. Another way to do this, was the conventional way to do this is just to go to your what mate command at the top at your assembly tab. Once you click on it, then you select the entities you want to mate. What are the entities you want to mate? You can't see them because they are not visible. So come here, click on origin, the origin here, and click on the second origin here. So automatically it will select what coincident, then align axis, then you click OK, then you click close. So if you have a lot of mates with you, that way you can still use that mates window to do anything you want to do. So it's always bad, it's always good to since you already know you already aligned your origin. Some people will go as far as what creating a new coordinate system to actually do, because according to your diagram here, going to your diagram, as you can see, there's a coordinate system showing here. So I think we should just add ours to avoid any issue later on. So let's just do that. So let's just go to uh, reference geometry coordinate system. So and we select what the origin. The origin is the y. As you can see, the y is facing the y. The x. Sometimes if you don't know where your y is facing and everything, from your own instinct, like here now, I don't think you can. Okay, there's a line here that shows where y, x, and everything. You can just input the direction where your x is. You all know that your x is along this line. You all know your y is usually vertical, and your z is usually along this line. In case you want to align it, but since everything is aligned, is properly inserted, you don't need to put all those. You just click OK. So we already added our coordinate system. You can give it a name. Let's click this arrow back. So as I said, the mate, any mate you use to be appearing here. So this is the first one I used. I suppressed. This is the next one I did. So I can just delete this one since you don't want too much mates to be involved in your work. So have we fixed this back? We've not fixed it back. So let's fix it. So as I said, just like your sketch environment, look at this bottom corner here. It's showing that what your components, all the components here, despite being one, is fully defined. That means you can't move it no matter what. You can't move any part. So it's always advisable to always work towards making all your parts fully defined when it comes to that, because you are going to be asked, they are going to be asking some intricate details, and if some parts are wiggling out of position, it can cause you to give the wrong center of mass. So you've already fixed that base. Check the time. I hope we are still on track. Oh, almost an hour. So we'll be done in a few minutes. So we've already imported our base. You already have our coordinate system one. You can rename it if you like. If you want to rename, you just need to tap on the particular part. Just put coordinates. That will be our coordinate system. So the next thing is you can now save your work. As you are doing everything, please always save your work. So you insert according to the instructions. Please go back to your instructions. Please. According to the instruction, it says what? And use the origin. We've done that. Bottom modes of the bottom link bar as well as pin. So we are importing By inserting bottom linkage and pin next. So bottom linkage, so you can hold control while you do that, or you do it one after the other so that you don't stress yourself. Let's just do it one after the other. You don't rush ourselves, because you can hold control and import it to them, but I don't want it to look overwhelming to you guys. So aligned, so you don't need to change this one already. You don't need to rotate it. So just click somewhere here. So as you click, so the shortcut, instead of going to this insert component and do this, they said this hole of the bottom linkage is coincident with it will hold your shift or your control or your and your control or your control key while you are selecting these holes. So as you select the both of them, it will bring the floating options. So is it parallel? No. Is it perpendicular? No. We don't want it tangential. We want it to work concentric. Even the most suggested one is going to be what I highlighted there. So there are other mate relations that you can easily add there, but we want it to work concentric. So immediately to make it concentric. So this part is for making it lock. You want to lock the rotation. We are not locking the rotation because we still want it to move. And this part is for flipping the alignment. You want to flip it. You want it this way. So the next thing is towards yes, our pin. And so you just click it there and select the two and make it work concentric. I hope it's concentric. I use the first time. So it has to be concentric, not coincident. Concentric. So as we've done that, the next let me save my work. My graphics card is not certified. Okay. It's not to start misbehaving around. So the next thing to do is to what? Outer faces of the bottom linkage are connected with the inner face of the base. Yes. So this is the outer face of the bottom link. So use your middle mouse button to revolve and hold your control key while you select the inner face of the base. So to bring the we want to work coincident. Now, if you notice your pin is still movable, you can move it anyhow you like. So the same thing, you have to flush it with this surface. Since it's the same, you have the same width. So click on this face while holding your control key and this face. Then you click coincident. So we've done the instruction 1, 2, 3. So the next instruction is what? Two pins are concentric to the top holes of bottom linkage as well as the bottom holes of the top linkage. So we are importing top linkage and two pins. So I guess we can just do that one, do both of them together now. But if you don't have the mind, if you don't have the just take time, look for the true pin and what top linkage. Hold your control while you import them. So you don't need to rotate it. Select. Remember, it's two stuff we are inserting. So let's quickly do this. So this part is concentric to oh first. Normally, if you are building something like this, you know this one has to go in first. The top linkage has to be concentric with the bottom linkage first. So let's do that first. This concentric with this. And this is concentric with any of them. So we've done that. Next is to make them coincident, right? Outer faces of the two pins are connected with the inner face of the bottom linkage. So can move them. As you can see, everything. So we have to make this our outer face of the bottom link page the coincident with the inner face of the top link page. You can see. Then we now make what the inner face of the bottom link page be what? Let's try to make it first. So we have to make this inner face be what? Just with this coincidence. So we've already done majority of the work here. As you can see, everything is properly fitted. So always use your middle mouse button to hover around what you are doing. Take notes. Very important. So you can just move it. So you're already getting there. You can just move it to like you know where you are headed, where you are headed, so that it doesn't look clumsy as time goes on. So top hole of the top linkage are concentric to the holes of the top parts as well as base. So the same thing. So we are importing our top part and painting top pin top pin. So pin first, yes, well top part. This is what I like. So look at this kind of scenario now. As you can see, it's not properly oriented. So you have to rotate along with axis. You can rotate it along and as long as you get the correct path. But looking at this, you are going to you can rotate it along the z axis. You cannot rotate along the y axis because the y now wrong. But the x axis, aha, zero else. Yes. So select. So let's make them concentric. Don't mind the way it is. So far as they are concentric, you can just move. But I don't want to move it too much so that it doesn't affect. This is also concentric with this. Okay, now let's make your parts is aligned to you. But sometimes you might not know, okay, maybe some of the words, some of the grammars in the instructions that maybe you don't understand them. So you can easily use your measuring tool to get that. How do you do your measuring tool? I have about shortcuts. We press our S now, as you can see, you have measuring tool here. You can use it to measure the width of this. So you know which one is this one now. Let's take the internal part. The internal part. This and this. You can see it shows what 36 mm. While for this and holding your control, instead of clicking on your measurements, the distance between those two faces I just selected now, this and this, it will appear here 60. That is to show that the width of this one is what is larger than the width of this top part. So that means this one goes inside this. That means you are making this face coincident with this face. Then this face, you have to make it coincident with this. So we've done almost everything there. We've not brought in our true road. Oh. See, it's very, very important. We skip this step by step. Let me check what did into it. So okay. The top. Okay. Now inner face of the, yeah, we've done that. Now full rod is concentric to the holes on both true pins. So only have one true pin first. You have to be careful not to implement. As I told you, we are working symmetrically. We are dealing with one part while we just use a mirror tool or something else to make sure the other part doesn't give us headaches. Do you understand? So let's import our rows. So we are following the steps one after the other. I think for now, that is the last component we are importing, we are inserting. That is our true rod. True rod, true rod. Here it is. So is it well we take it along our watch like this to select. So this part is concentric to this. Okay. Then we now said the next rule states that the inner rim of the true rod is tangential to the outer face of the left true pin. So this is the inner face, the inner rim of the true rod, tangential to the outer face of the left true pin. Take note, please. That's this face and this face are what? Tangential. So I basically done with everything. So what is the next stuff that required? Now they now said the true rod is horizontal relative to the base. So now there is no way we can relate curved rod with this base that will make it to parallel to the top because we are looking for a parallel constraint. Do you get? So what do we do? For each component, all of them have their own individual front plane, top plane, and everything. That means we want to make the top plane of the rod parallel to the what? To the face of the base or another flat face of the base. So these are true rod. We click on the top plane and we click on the face of this. Make it work parallel. So do you understand? So basically we are almost there. Now the next thing I know people might worry that how will we now do it that this remaining parts will not be. You can do it one after the other too by importing and doing exactly what you did here without importing this part and this for other remaining parts you have to import and the true rod for other parts you have to import. But to avoid this, you can just use a feature that has helped me a lot of times. It's called copy with mates. Remember to always say before. Wait, do that. Next is the top face and the bottom face are parallel. Okay, let's do that too. Top face and the bottom face are parallel. Let me check. I'm going to check the chat now in case there's any question awaiting me there. So they're already parallel, and the distance between them is what? The global variable. But before we get there, let's just calm down. Let me say my work. Let me check if there's any question in the chat waiting for me. Okay, are we getting the recording? Yes, as I've said, Mr. Oye Jebu Jelupechuku became. Yes, you are going to get it on YouTube. Yeah. Really. Alhamdulillah has already even replied. So I hope you guys are getting what I'm explaining so far. Please, if you don't understand, let me know so I can just go back. So now this feature is called copy remit. So you see these parts that are repeated, that are copied, your bottom linkage, your top linkage, and their corresponding pins, they are repeated. So we are now going to use a feature called copy, copy remit. So let's do that now. The bottom linkage, hold your control, not your shift linkage. the top linkage, the bottom linkage pin, and the top linkage pin. So those are the four components you need. So I click on them and choose copy with mates. In case you didn't select all the required components that you need, you can just select them here before you proceed to the next system. So copy with mates just tell you that okay, those parts you copied right now, where are their corresponding mates? Let SolidWorks help you compute them. So concentric, there's a lot of concentric. There's a lot of what? Coincidence. So you have to be very careful in this case. I don't know if I should teach you the but like a shortcut, sha. A shortcut, because you're going to need something like this in the exam. Now, concentric, the first concentric, as you can see, the part that is in purple is telling you that this is where you use the concentric feature for the last time. This face, this inner face. Okay. That means our corresponding inner face that I want to use it is what? This face. Now, if you look at the skeleton of what to import, this is the second copy of what you want to copy or what you want to paste. You see its direction and we don't want it that way. We want it facing it up like symmetrical. So let's just click on this flip mate alignment. If you click on flip, it's going to make it work face the other side as you can see here. So that means some parts have changed to like the faces you are going to be aligning your parts to. But all these things, even if you make a mistake, you can just easily go back to your mid section, delete or you edit. You get there is no permanent damage done here. Now the next concentric that is being highlighted here is for the what? I'm sure it's for the pin. Pin 2 is still aligned to this hole here. So let's click on it. As you can see, its shadow has already what? Its skeletal this thing has appeared. This transparent form has appeared there. So the next thing is coincidence. Be careful with this coincidence issue. Now, coincidence. Instead, you aligned this yellow part of your previous linkage to this purple part of your previous base together. So now, currently, is now telling you that where do you want your own new, this face of your former bottom linkage is the same as this face. Please pardon me, I need to quickly attend to something. I'll be right back. Just give me like 2 minutes. Sorry for that short delay. So as I was saying, please you have to be careful when you are doing this. So the coincidence, you have to be very, very careful. So this phase is what is not going to be aligned to this phase anymore because this previous phase here, this is it here. So you are going to select another part for it. So that means instead of it to be aligned to this purple shaded part of the base, it's going to be aligned to this part here. I hope you understand. Because if you select it here, that means you want this part to be aligned to this same place, which is impossible. You get. So the next coincidence is what? So it's telling you that this yellow is aligned to this yellow. So for this one now, if we select this part, it's going to be perfectly because this one is not. We didn't change its orientation. We didn't change its alignment. Do you get? Please don't be confused. Now you see the parts of concentric relating to this one. Let's just leave it for now. Relating to the true rod. Because I know this one is for the true rod. Same goes. Have you? Yeah, it's for the true rod. So the next coincidence is what? This face uh this face to the true rod. Let's leave that one too. Oh wait. I did not even select. Oh no. No wonder, no wonder, no wonder, no wonder, no wonder, no wonder. I did not select the true pin. Should have selected the true pin. Wait, let me go back. Select the true pin. I'm sorry, I apologize for this. The true pin too is also needed. Then next, I hope it continues. Oh, we have to start over. Okay, concentric first. Where's our first concentric? As I said, here, we'll be fast now. We'll flip the face. The concentric next is still this hole. Then the coincidence, as I said earlier, it has to be this new face. Coincident of this one, this face. If this the alignment, uh, you have to be careful. Sorry, the coincident constraint. You have to be careful in this case because this is the top part, so you have to know where it's supposed to face. Since this one is facing this side and you've already changed the orientation, that means it's supposed to be facing this other edge here. So let's be very careful. So if it's the whole part is facing this part, that means part is facing this part. We we did right. Uh, nah, let's do that. Let's do that. Okay, what is it telling us first? This face, this face. Okay, we did that. This face also to this face. Okay, you can't use that. Can't use that. Can't use that. Don't get it twisted. I'm coming. It's so common, common videos. Natural consent. If you are not doing this tangent and so this one is just next one. Oh, there's a conflict. Okay, let's just stop here. Let's click select and just see where our model has taken us to. Let's calm down and just align everything well. Let everything does not go wrong. See, we're already getting a little bit confused. I just hope I'm not confusing you more than it should be. Apologies for this little mix up. Mm, let me control Z this and try it again. Okay, or let's do it this way. Let me add the required flush first. Do you get? Let me add the required distance between these two faces. This and this. So there's a distance relation between two of them. A and B, we can't enter our global variable here. I doubt it. Let me just try to take maybe it's enter a number greater than blah blah blah. Okay, let's just put 200. This and this one. Okay, it's at 400 here, right? Let's make it at 450 and just click OK. We'll change it. You can just realize. Yeah. You come to where the mates are. You click on the mate to give you the value. So you double click on the value to change it. Then you can now say you're equal to that you've entered before. So you reviewed. Okay. So we've done that now. So let's see. From here we can now do what is necessary to copy with it. I hope it works this time. And if it doesn't work, that means you have to just stick a basic importing again or mirroring. But this is usually faster. It's just that sometimes if you have a lot of coincidence, gives this error. So then we go next. Where's our incidents? Let me even make this one coincident first. Flip this. Flip this part. Coincidence. This and this. Careful when you are doing this place now. So that enter our next coincidence this place. It's set to the bottom side, the top part side we are looking for now. I think everything is already going well. Now concentric. Let's give it to this flow here. So let's flip it. I think it's that flipping that we didn't do. I mean that. Oh my god. Delete. Let me do the top part first. Apologies. You don't have to do this thing like few hours ago without any pops. You know, like, look at this I think the orientation changed somewhat. I think we have to just stick with the basic importing now because copy with mate is giving me unnecessary edit here. Uh, sorry about this. Sorry, let me just yes. Or we just do it one after the other. Maybe that works well instead of copying everything out. This one is not placed here. Just this constraint. So I think it's better we do it one after the other. Now, please don't be ahead for this. So let me just click this and just do it. Copy with mate. So how we copy with mate? Just bottom, concentrate, leave. Second concentric, we leave that because it's dealing with the parts that are dealing with the incident and now these parts. So let's see this first. So instead of using copy we made, I think we have to pause on that. So that it doesn't confuse you guys and you don't spend too much time in your exam. So let's just hold the shift key and click this. If you hold your shift key while dragging another component, that means you want to copy and paste it. You want to copy it. So that's what we want to do now. I've done that for this. So concentric, concentric. Hope you guys are following me now. We are already back on track. Then coincidence and coincidence. So we've done the same thing for the base. So same with this. Hold your control and everything. So for this case now, is this part that we are meeting with this part, this whole here. Now, then make this face coincident with this face. Now, as you are doing it, you get the hang of it. You don't even really need to be looking at anything again. So let's try to face this one. Try to zoom it very well. Ah, so this through pin, control, and drag. Control and drag. This coincidence with this. Sorry, concentric. Then this face concentric with this face. Hope you guys are getting me. So let me check the group chat in case there's any question so that I'm not okay. Miss, thank for the correction. Miss Oyeche. Or you pronounce it for us after the lecture so that we will understand. Everybody will know how to pronounce your name. Sorry if I made any error in pronouncing your name. So let's continue. So we've done that. So the next thing is to make this one concentric with this bow here. Then the next thing is also make this part, this bow here concentric with this. So as you can see, you guys need to be very careful when working. Okay, so we have one more pin left. Just copy control. So I think we are done basically with it. We've done the required global variable. Is there anything we are missing? Distance, we click on this. Is our 297, right? Let's confirm. Find the center of mass for it. A is what 219. Alright, so let's see. Got the answer. So how do we do that? Save your work. Remember, your first question determines two or three other. Your first answer determines like the validity of two or three other answers after it, subsequent answers. So if you fail the first question, it's very likely you fail the remaining two. It's not even very you will fail the remaining two. So always make sure you get the first answer first correctly, and it will always be your option. So you just select it, then from there you change your global variable. So let's check. Did you get it? Aha. I don't think you got it. You are missing something. Mm, what have you done correctly in the ground? Let's try to remove anything we use. Incidents. Why is this? So in case you are encountering any error, it's always good to check all your notes properly. Are they working as supposed to be? Like the part that is suppressed. Why is it suppressed? Oh, oh, maybe because I fixed it. Yeah, I fixed it. That's right. So concentric and location of this one. Location is very important for all. You don't need to really draw this log quotations, but just have to show there is anything missing. Let's check the question again. So the answer is minus 2.43 amplified. So it should have been wrong. There is something missing. As I said earlier, any misplacement of parts is even good. Is the way I'm making mistake is very good. The way I'm making mistake so that in case anybody is working on it, because we two are not perfect. Although we have to really check our computer very well and review it if possible. Very review 297. Sorry, we're almost done with the session. I just need to be sure where the error came from. And another way of checking if maybe any part is intersecting with any other part. Now only comes to evaluate and do an interference detection because no part must interfere with another. So if we calculate, if we notice any interference, that means there is an error. Okay, so an interference here, an interference here. Oh, I see where the mistake came from. Look at our parts. Look at our first part here. Instead of it facing the flat face facing outside, it's the inner face that is facing inside. You get it? So that's where the error came from. I think it occurred during that time I was doing my same goes for the bottom too. Look at when I was doing this copy with me. The copy with mates this night I still used it like a few hours ago before the class and it worked. But look at this well, you see what we are saying. You have to be very, very sure. So what you just do in this case, instead of starting all over again, you are going to click on each of the components with the issue. You click on this now, you see it's highlighted here. Then click on the top there. The mates, all the mates required of it, you have to suppress them or delete them first. Then you now want to make them back. That's how it's basically done. Like the concentric, we try to flip it. Let me try to flip the concentric. Okay. Alright, to affect this component. No. Then any other error. No. So coincidence. This coincidence means you have to delete it. Coincidence. You have to delete this coincidence. So this one, delete. What about this one? Delete. So the concentric and still manageable. So let's do the same thing for the bottom linkage. Which scroll down, check its weight, concentrate, and let's delete all the coincidence. Coincidence, delete it. As you can see, it's not concentric. I think that's where the error came from initially. Concentric, concentric, concentric. Let's flip it. So I've done the bottom part first. Concentric, see ready, ready, getting there. And so you can move there. All we want is what? This concentric with this. That's why a coincidence with that. Then this should be coincidence with this. Nope, 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 nope. Let's go back to it. So any mix just will be showing up here. Delete this. This coincidence. Hope you guys get it. Hope you guys get it. Then you know what that means. Okay. This will influence this. Concentrate. Sorry. This coincidence with this. There any moving part between. think everything is going to settle. You see what I'm saying about misalignment? Any little misalignment, you have issues. So always check your company. I even like the way I made it. I think the mistake I made is kind of a blessing in disguise. Is to show that in case you're having any errors, even pros do make errors, but you have to be very careful so that it's not very costly error. So let's check our interference detection again. So to select the interference. So as far as you don't have any interference, then you can I think we are good to go now. Save and rebuild the S mask of the exactly. You see what I'm saying? The center of mass now aligns with what we got here. Minus 2 x on the x coordinate is minus 2.43, the y coordinate is 125.66, and our z is what 0 mm. So that's what I'm saying about always making sure that everything is in the center of mass. You won't be asked for mass, you won't be asked for volume. Surface area, the center of mass is very, very key. And if your answers is not in decimal code, you can just come to this option here and what use custom settings and change anything you want to change. But I'm not doing that. Yeah. So far as you've gotten the response, you should be rest assured. The next question will be like change the global variable to this, change the global variable to that. So since we are done with this, so we can now what save as everything. So save as go for Q20 is the first one. So this one will be Q20. So the next question says updates. Sorry. The next question, Peter says updates our global variable to 440 mm. The same details as before, provided as before. So just go back to it and just change it. Where do you change it? You can just easily change it here. No, you can't change it here. Sorry, you have to go to your equations. Manage equations. 420. First answer. Automatically it's going to what? You know, it's the distance between all the two of them. So that already was changed. So let's check our center of mass minus 0.46, 152.94, 0.46, 152.94. The reason why your Z is 0 mm, I hope you guys know that because our Z is what is still in our ground position. That's why they said your coordinate system matters. So imagine if you did not align the origin of this your base part with the origin of your assembly. Your Z will be a plus or minus value. I hope you guys are getting me. So it's just basic math, how do I put it? Geometry, basic Cartesian stuff. If this your base now, you you normally your base is at 0 and your as you imported your base, you didn't align with your origin, and maybe when you just fixed the base is at maybe z is equal to 10. It's going to be showing that z is equal to 10. I'll show you that. Z will be showing that value. So let's be careful when we are calculating the center of mass. So the next question 612, change to 612. So equation. Oh, you have to save as first. Remember, you have to save as U22. Save as copy and open. So if you've done that, you can now go ahead. Go ahead. Manage equation. 6 1 2. Do you not? Okay. So let's check mass property. So our center of mass is 272.24. 6.14, 272.24 divide, and Z still 0 I hope everybody understands before I proceed. Let me go to the chat section. I know if you guys are following. I know you guys, some of you might have been lost during that time I was having issues with my copy admin. Mr. Gerald, Mr. Adebola, Mustafa, Paul, Kayode, Jenitope, do you guys understand what I've been saying so far? Can I proceed? Please, I'll need a verbal comments before I can continue. Hello, hello, anyone? Hello, anybody here?
Someone said proceed. Oh.
What do you say?
I said someone said you
Okay,
can proceed.
all right. Apologies for the delay during the copy with mate session. So, so let's just do a summary of what I've been talking about so far. So, like I said, everything still boils down to what read and digest your questions well, ensure your units are well, uh, uh, your units are well entered, like it matches what is required in your question. Then number three, your material. Make sure your materials are very important. Please always make sure your materials are entered correctly, are chosen correctly. Then save your work. Each answer save as copy and open. Please always note that. Then number five, fully defined. Yeah, your sketch should be fully defined. Your assembly, not really, but sometimes all your assembly must be fully defined. But some among the steps, they will even give you that. They will tell you that they will even indicate it there that you should lock a particular mate, or you should lock a company, or you should make sure the component so that you know that it's fully defined. But it's not every time it applies, but always just take notes. Because your assembly question should be two questions that you're going to assemble. Please always take notes. Then number six, please be time conscious, very important. As I said earlier, CSWA, it is very advisable to finish 30 minutes before the allotted time so that you can go through your questions to determine which one you made mistake, the one you skipped earlier that you couldn't answer because of difficulty. So it's very good to always have that much time so that you can just use it to cross check, dot your I's and cross your T's. And have fun while doing the exam. It's a simple exam. It's a basic, it's the number one exam, so you shouldn't have much issues. And I'm not saying this to discourage you, but in case maybe you're having difficulty while doing the exam, maybe the exam came out, the result came out, because it's usually immediately, and maybe you didn't pass. It does not matter, you can always do it another time. Most of us here that are already CSW is even CSW they failed exam before, and it was not the end of the world. It doesn't mean you are not good. Please don't take that to heart. But I know most of you, all of you will go pass because this is basically all that CSW is all about. So thank you very much for attending the session. Any questions? Hello, any question? Is there anything you don't understand that you like me to go over again? Hello, ladies and gentlemen. I think, all right. Thank you, Mr. Gerald. Uh, I think that will be all for on CSWA. For those of you that usually ask about if the videos will be uploaded, of course they will be uploaded. That is not an issue, but it's always pertinent to always, be there in real time to ask the person taking the tutorials so that anything that you have issues with, you can just relate to him directly. Because after, if you are watching a pre-recorded video, to ask questions sometimes, or maybe you notice that maybe the instructor was doing something wrong or something, so that you'll be able to like correct him or anything. But you have to be very, very, very sure of that. So it's always good to always pay attention. Thank you very much, Mr. Gerald. Thank you, Temitope. Thank you to all that attended. I think we'll be ending in 5 minutes. So in case anybody has any question, copy with it. You really showed yourself today. Wow. It's still surprising because I was not like this thing I did. So no questions. Still get. So thank you very much. I think we'll be ending now. Okay, there's still 2 minutes left. Bilal, over to you. Hello, Bilal. Copy this way.